In this video, we're going to talk about the homework worksheet 12.3 geometric sequence of the easy part. So for the first question, we have to determine whether each of the following sequences is a geometric sequence. So first of all, you need to remember if we have a geometric sequence, which means that they have a common ratio. So we have AR squared, all the way for the nth term is going to be AR to the power of n minus 1. So we check for the first part. The ratio between them is equal to 8/2, giving you 4. And we have 32/8 is equal to 4 as well. So for 168 divided by 32 is still equal to 4. So they have the same ratio. So yes, they are the geometric sequence. So for the second part, as again, the ratio is going to be times -5. And for the second part is times -5. And for the third part is still times -5. So as again, the same ratio, which is equal to -5. So yes. So for the for the third one is definitely not, because the ratio between them is quite weird. So it's actually, if you're using the calculator to calculate 2.2 divided by 0.2, it's actually giving you 11, but actually 12.2 divided by 2.2 is actually not equal to 11. So actually it's no, because they have not the same ratio. So for the second one, the first term and the common ratio is actually A and R respectively, and let Tn be the general term. So we have T2 is actually equal to A times the ratio, and then for the third term is actually equal to A times the ratio times the ratio. So giving you the answer of AR squared. And then again, we have T4 just equal to A times R times R times R, giving you AR cubed. So similarly for T5 is actually equal to AR to the power of 4. So as you can see that when this is 2, then the power is going to be 1. When this is 3, the power moving to 2. When this is 4, the power still be 3. So when this is 5, the power becomes 5 minus 1 equal to 4. So for Tn, just going to be equal to AR to the power of n, no, but with an n minus 1. Okay, so that's for part B. You have to remember this general term of the Tn, okay, the nth term of a geometric sequence. Okay, so for the third questions, in each of the following, the first of term A and the common ratio R of a geometric sequence are given. So we have to find out the general term and the fourth term. So if you still remember that, the Tn, the general term, can be using the formula of AR to the power of n minus 1. So try to substitute these two numbers back into this equation to get your answer. Alright, so for Tn, just equal to A, which is 5, and then the ratio is 4 to the power of n minus 1. Okay, so this is going to be equal to 5/4 times 4 to the power of n. Or each one will be going to be fine, because it's going to be simplified as well. So this answer is okay. So for the next part, we have to find out the fourth term. So for T4, just equal to 5/4 times 4 to the power of 4. So this is going to be equal to 4 divided by 4, giving you 4 to the power of 3, which is going to be equal to 64 times 5, giving you the answer of 320. Okay, so for the next part, we have the A, the first term is equal to 2, and the ratio is 1/2. So for the Tn is actually equal to AR to the power of n minus 1. So for A, we have 2, and then for the ratio is actually 1/2 to the power of n minus 1. So we have our T4 is equal to 2 times 1/2 to the power of 3. So you can use the calculator, which is equal to 2/8, giving you the answer of 1/4. Okay, so for question 4, a geometric sequence is given, and we have to find out the general term. So please bear in mind that for general term, what we need is just the first term A and the ratio R to the power of n minus 1. So try to find out what is A and what is R, and then pause the video to do it yourself. Okay, so the answer should be the first term, just the first number here. So we have the A is equal to 5, and the ratio just using the second number divided by the first number, which is times the 2. So the ratio just equal to 2. So our Tn just equal to 5 times 2 to the power of n minus 1. Okay, so for part B, if the kth term is actually equal to 80, so for the kth term, we can actually write it as tk, isn't it? So if tk is actually equal to 80, then we just substitute this back to our general term. We have 5 times 2 to the power of k minus 1, which is replace this n to become our k. Okay, so this is equal to 80. So we have 2 to the power of k minus 1 equal to 16. But 16 is actually equal to 2 to the power of 4, isn't it? So now we can have the power is actually the same. So we have k minus 1 equal to 4. So k minus 1 equal to 4, so that the k is equal to 5. Okay, so for a geometric sequence like this, find out the general term. So as again, try to pause the video by yourself and do it again. So we have Tn is equal to the first term a times the ratio to the power of n minus 1. Try to find out what is a and then what is the ratio. Okay, so the number at the first part is going to be our first term. So our a is equal to 1 over 36. And then we have the ratio just equal to the whole thing times 6, isn't it? Times 6 times 6. So the ratio is going to be 6. So which means that our Tn just equal to 1 over 36 times 6 to the power of n minus 1. And now we say that the kth term is 216. Again, we just substitute the tk equal to 216. But what is actually tk? Tk just substitute the n to become k. So we have 1 over 36 times 6 to the power of k minus 1. Okay, so now we can say that 216 is actually 6 to the power of 3, isn't it? And we times this 36 to the left-hand side, so times 2 squared is equal to 6 to the power of k minus 1. As the base are the same, we plus the power together to get 6 to the power of 5 equal to 6 to the power of k minus 1. As the base are the same, we just compare the power, so we have the k just equal to 6. Alright, so for the last question 6, the first term and the fourth term is actually equal to negative 4 and negative 108. So find out the general term. So for the first term, we can write as T1, isn't it? So T1 just equal to negative 4, and sometimes we can just using A to representing our first term, isn't it? And we have T4 can be writing as AR to the power of 4 minus 1, and giving you the answer is equal to negative 108. So try to substitute our T1 back into this T4. Then we can say that this is equal to negative 4 times R to the power of 3, because 4 minus 1 giving you 3. This is equal to negative 108. So we have R cubed is just equal to 27, which means that the ratio is 3. Okay, so this is for part A. For part B, if the kth term of the sequence is 2916. So kth term, which means tk, is negative 2916, negative 2916. And we change the k to become the, sorry, I haven't written down the general term. So for Tn just equal to ARn to the power of minus 1. So we can say that's the Tn is equal to A. What is A? A is negative 4. And the ratio is 3 to the power of n minus 1. So now we can say that the kth term is just equal to negative 4 times 3 to the power of k minus 1. We just change this Tn, the general terms in terms of n, change the n to become k, so we can get the kth term. It's actually equal to negative 2916. So we have 3 to the power of k minus 1 is going to be giving you the answer of 729. So 729, if you still remember, is actually 3 to the power of 6. So we have 3 to the power of k minus 1 equal to 3 to the power of 6. And then giving you the base at the same, we just compare the power. So we have the k just equal to 1. So that's for the easy part. So if you have any question, don't hesitate to ask.